welcome everybody to Johnson County Community College Astronomy Department evening, semi-annual evening with the stars. I'm Professor Cook and my partner, Professor Patterson there. We're basically the astronomy department here at Johnson County Community College. Most of you know us. Tonight we have the good fortune of hearing a speaker who's a friend not only of ours but of the department. He's got his degree in biology, but we'll not hold that against him. He's going to be talking to us tonight about some impact events in our backyard, talk of which he's given several times. And he's also the keyboard player for a local rock and blues band, KC Aces. Maybe some of you have seen him around town. Or he's given up a gig to be with us here tonight and do this talk. And from the looks of the ammunition up here, I'd suggest you pay attention, or you might see a rock coming your way. Anyway, so please welcome Mr. Leo Johns.
Hi, I'm Leo Johns. It was funny to hear a slightly uncomfortable giggle around the room when he suggested he might pick up one of these rocks and wing it your way, because what we're going to be talking about is not rocks thrown at 10 or 20 miles an hour by your astronomy professor, but we're talking about rocks at 17 to 20,000 miles an hour impacting Earth, one of which I'm going to tell you about tonight was roughly the size of Arrowhead Stadium. And believe me, when these kinds of events happen, they get your attention. So we will discuss that. Once again, I'm Leo Johns. I'm a student here at JCCC. I'm taking Mary Harmon's genetics class, and also I've got statistics from Jacob Epstein, so you might see classmate. I don't know, I can't tell. We're going to be talking tonight about round rocks, Doomsday, and the Missouri meteor strikes, the geology of Earth impact craters, and the Weaubleau Osceola structure. Don't be scared off by the word geology. I know it's not in the astronomy area, but in science we do see a lot of cross-pollination exactly and currently because we see a lot of data because of the power of technology and computing now. There's a lot more data available than there is, and so a lot of disciplines are starting to cross over from one to another. So if I cross the areas, it's just because I don't have a degree in astronomy, neither do I have one in geology, and I'm crossing over because I'm just a hacker that's applying his head towards stuff that's interesting, and so I challenge and encourage you to do the same thing. What I'm asking you to do tonight is be Curious George. Now, Curious George, of course, is the monkey who's always looking through the binoculars because he has a curiosity about everything. We're going to talk a little bit about binoculars later, but not much about monkeys. But keep Curious George in mind because he might pop up in just a little bit. Curious George sees a lot of signs and wonders, and he doesn't know what they all are. So I thought we'd start with a little quiz. Now, if anybody is my social media friend, they might have seen this slide before, and so I'm going to ask you to guess what this is, and we'll spend about 30 seconds maybe taking a couple of hand raises to encourage thought and to encourage participation. What we have is a photograph, and it might be anything. Remember that I'm a father of 4. I'm in a blues band, and I have a biology degree, not a astronomy degree, so what do you think that could be? Any impressions? Raise your hand or call it out. There's one. Go. What do you think?
Shadow of a plant.
It looks like a shadow from a plant shadow, maybe taken through some kind of a diffuse photography filter.
I think it's a tattoo.
It's a
Tattoo?
yeah, it looks like a tattoo, like maybe a neck area, a tattoo right at the neck, and maybe this here is the neck, or maybe this is like, you know, that swimsuit deal coming across or something. I don't know. Any other guesses? I mean, this, you're right. This looks a lot like skin tone right up here. As a matter of fact, it looks exactly like skin tone. Any other? Maybe a couple more.
Desert.
It's the desert, like a aerial view of the desert.
Yeah.
Any others? This actually, you're close. This is actually a shot of the surface of Mars taken from the Mars orbiter. This area is a high desert plain, and these are sand dunes from a high area that have been blown and rippled by the wind. And the interesting thing about this is that the large scale, science looks a lot like it does at the small scale. the chaos of a high-scale photograph of the surface of another planet looks a whole lot like a close-up of the lady's skin, when you think about it. These trails here are the long trails in the dust of dust devils. They're like little miniature tornadoes, little windstorms that last 5 to 10 to 15 minutes, and they'll kick up on the surface and they'll sort of roll along and take the sort of top iron-rich soil off the surface of Mars, and they'll curl around because of the wind. And these are all trails and smears by straight-line windstorms at probably high elevations and hills. And that's exactly what that is. If you'd like a reference for that, see me later, and I'll be glad to tell you what that is. Curious George is always trying to see what there is that's interesting, and I like to give everybody a chance to have a bit of a dream.
Sir?
Yes?
What's that big barcode thing at the bottom?
The barcode-looking thing. From what I read, this is a higher elevation, so the wind hits this area here, and as it does, it creates straight line events. So the wind that's kind of swirling here in this sort of lowland valley hits this rising area here, and it forms these sort of straight line little crawlers. But only these are straight line crawlers. I mean, these are just like, you know, dust devil wind trails. And it exposes the darker rock that's underneath the sort of orange-red rock that's been probably exposed for millions of years on the surface of Mars. So you win you win a round rock. At the end of the lecture, come see me and I'll give you one. I'm one of the few people you'll meet that was born in an Earth impact crater. My birthplace is Norfolk, Virginia. And in the early 80s, because of some oil exploration in the Chesapeake Bay, we discovered the largest United States impact crater, which is the 6th largest on the planet Earth. And it, in fact, defines the entire topology and geography of the Chesapeake Bay region. Of course, the Chesapeake Bay region itself is glacial melt that's coming down from the old ice age. This particular event is about 50 or 60 miles across. It's twice the size of Rhode Island and is a bit deeper than the Grand Canyon. It's enormous. 35 million years ago in the Eocene, which is relatively recent in geological times, Weaubleau, which is a giant meteorite, came through and impacted. It fractured the basement rock and formed a peak ring. And we're going to look just a little bit at the topology of Chesapeake because it applies to something else that I want to teach you about. Now, I was born in Norfolk, Virginia, which is right here. And you can see that when Chicago was buried under a mile of ice about 12,000 years ago, and the glaciers retreated, the ice melted, it formed this giant alluvial plain, which formed the remains of this river down here, and the entire Chesapeake Bay is alluvial. And so right in here, Norfolk, Virginia, you'll see where the crater, and I'll overlay that. This is from Google Maps. Here we have Virginia Beach, and Norfolk is right here. Next to NASA Langley, which is right here between Hampton and Newport News. And you'll see that the inner rim of the crater and the outer rim of the crater barely touch and shape the tip of Norfolk. And DePaul Hospital is right there. That makes me one of the few guys you've ever met that was born in a meteor crater. As a matter of fact, there is only one municipality in the United States of America that's entirely contained by a meteor crater, and that is the town of Vista, Missouri, and we will get to that in just a few minutes. Now, the Chesapeake Bay crater location is once again overlaid in this slide. The outer edge here and the inner rim. This is a slightly redundant slide, which I'm going to gallop through. Actually, I'm going to gallop through a lot of technical material because I want to. When we have a night like tonight where we get the chance to go on the roof, we prepare 2 different series of slides. One is called the cloudy night version, which means I'll talk for maybe an hour or 10 or something like that in case there's nothing else going on later. Or tonight's the clear night version. We'll skip a few things because we want to get up on the roof and take a look at things. So this is the clear night version, and we'll skip just a few things. Chesapeake Bay crater was discovered in 1983. And how was it discovered? Well, in this case, believe it or not, there was a lot of topology and elevation mapping that led us to this discovery. And also we discovered something called tektites, and these are small molten pieces of rock which were dug up when the impact happened 35 million years ago. The key piece, or the 2 key pieces of evidence are what we call the Exmoor breccia. And breccia is a type of rock that's been subjected to severe stress. If you'll think of that bad Jell-O salad pudding that they feed you at Thanksgiving at Grandma's house, where they take Jell-O and then they put a little bit of pineapple here and a little bit of cherry there and a little bit of all the stuff sort of all mixed up. That's sort of like breccia. It's just these bits and pieces of rock that are all jumbled up and then remixed together like they've been through a blender. If you see breccia, you can be assured that something interesting has happened in the rock. Also, we see something called sharp quartz. And if you look at this picture right here, which is a micrograph, a microscopic image of a piece of quartz, you'll see it has these little striated planal fractures in it called PDFs, and they're little deformations in the quartz. And so this is how Chesapeake Bay looks, and once again, this is the key right here. This was only discovered in 1983. This is all recent science. And so what we can do is say, science is out there, and even guys like you and me can make great discoveries, and this is what I'm going to talk to you about tonight. Now let's look at the Chesapeake Bay crater. Once again, not because we're terribly interested in Chesapeake, although it's the largest in the US, but it does apply to something I'm going to show you later, which happened in our backyard. This is a complex crater, and this is a diagram of the side view of this crater. Notice that we have the striated layers of the rock. Here's the sedimentary beds that were laid down over the basement rock. They were laid down over the basement. The sedimentary beds cutting across like this. When the object came down, crushed into this area, if it had been small, it would have formed a simple crater, which would have been a big scoop. But here, we have a big rebound that occurs right in the middle, because that thing had so much mass and energy coming in at interstellar speeds, 20 to 25,000 miles an hour, even if it was sitting still compared to the Earth, which in its orbit around the sun, from your intro astronomy, is moving at some 17 to 20,000 miles an hour, right, Bill? Mm-hmm. Even if it was sitting still, although that's not really relevant because Einstein explained in 1905 that there's no such thing as a still reference point, the Earth would smash into this thing and it would be like an enormously energetic event. In this case, it formed this giant rebound. In other words, it's like a splash. It shot up, hung out there until gravity brought it back down, and it splashed and made this deeper hole with this sort of little uplifted area right in the middle, and then these basement fractures headed down. So let's look at some, let me skip past that and show you what this crater morphology looks like. Here's the complex crater that we just looked at, like Chesapeake. It came flying down. You have this uplifted area because it was a very high concentration of mass and a tremendous energy, and it shot up in the middle. The simple crater is similar to what you would see if you took a puddle of mud, you dropped a little pebble in it. It makes just a little dent, leaves the rock at the bottom. In this case, the rock's all fractured up and mixed into the breccia right there. This is called the impact melt. Those are pieces of rock, and this is the brecciated area right in there. So let's scoot back up a little bit. These are the largest impact craters in the United States. We have Chesapeake Bay, 35 million years ago. It's about 90 kilometers across, and it's number 6 in the world. It's relatively recent. Like I said, 35 million years ago is not a long time. We have Beaverhead, and by the way, Chesapeake Bay is underwater for the most part. So would we consider that heavily eroded or lightly eroded? It's heavily eroded, and as a matter of fact, you can't get in to take a look at it because it's hundreds and hundreds of feet under the water. Yes?
How big a crater would an asteroid the size of Texas leave?
If an asteroid the size of Texas impacted the Earth, I think it would be Armageddon, my friend. That's a big piece of rock to hit. It would restart a lot of things, and maybe even you and me. So that's my personal opinion on it. We're talking about objects here that are the size roughly of, you know, the GEB building on this campus. And that's what would make Chesapeake Bay, the rock, a little bit bigger than that. Maybe the size of the sports complex. You know, the size of St. Thomas Aquinas High School. So, Chesapeake Bay, which is underwater, so therefore heavily eroded. We have Beaverhead, which is in Oregon. Now, Oregon is over there on the other side of the Rocky Mountains. And the Rocky Mountains, of course, as we know from our intro science, mountain building is due to plate tectonics and mountain building. So we have heavy erosion and earth changing, and also this is very old. You can see 600 million years. Much, 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 much older than the dinosaurs. And then we have Manson up in Iowa, which is just a little piece up the road. And once again, it's about 30 to 40 million years old. It's 35 kilometers across, which is still a pretty good sized hole, and it's number 23. in the world. But once again, Iowa, north of the Kansas City area, which was about the southern edge of the glacial scrape, has been heavily eroded because this enormous ice sheet with the pressure of a mile of ice came and it scraped the top of this crater off, and so there's not much to see. It's all like hacked up and scraped away. So what I'm pointing out is that we have huge erosion, and huge erosion. So what we'd like to do is find a crater that's not particularly eroded. Now, I'm going to skip through this real quick. In the early days of the Earth and its development, we saw intense bombardment, and this is where most of the moon craters came from. There was a period about 2 million years ago, 2 billion years ago, 4 billion to 2 billion years ago, called the Hadean period, and we saw enormous impacts of the Earth and the moon. As a matter of fact, current theory holds that the moon itself might have been caused by a collision during this time period, because the moon itself is about 4 billion plus years old, and it probably was ripped from the Earth because of a collision in the protoplanetary development stage. We had high rates then, much lower rates now. We have a great many sites over 100 kilometers wide on the moon and on Mercury, and indeed on Venus, although we can't see as many on Venus because it's got the carbon dioxide clouds. So the rates now are much lower, 1 or 2 every 1 million years, which means hardly ever. Every now and then you hear about a meteor impact that makes the paper, but it's very unusual. As a matter of fact, it's this unusual. I was in Jacob Epstein's statistics class about 2 weeks ago, and he was reading a statistic from the textbook, and it was talking about the chance of getting hit by lightning, and then the chance of getting, killed by a rattlesnake. And then he said the chance of being killed by a meteor is 1 in 8 million, or 1 in 4 million. And I didn't really care to offend my professor by raising my hand and saying, now let's talk a little bit about that statistic, because there are a lot of ways to derive them. You should know that, you're the professor, and we had a very delightful conversation about it. But there's never been a recorded case of anybody being killed by a meteorite or a meteor strike. No one's ever even been hit by a meteor, although there are 2 substantiated cases of people being indirectly hit where something bounced off something else and then struck them, and they were slightly injured. So it's not like, at least in recorded history, it's never happened. So that's why we say maybe 1 million years statistically. We have a total of 170 identified craters on Earth, and then we have other craters that we suspect are impact craters, including the one at the Weaubleau Osceola structure, where the rocks I'm going to show you are from, and we're going to get to that in a moment now. I want to talk for a moment about the qualifications for crater status, because there are metrics that they use to decide whether or not something's a crater. First of all, we take a look at the general geology. We know what breccia is. If the rocks are all crumbled up like the Jell-O salad at Grandma's Thanksgiving, then we might have had some kind of an event going on. We look for trace elements. We look for inverted strata, which means a rock that we know is 50 million years old on top of a rock that we know is 25 million years old. And if we see that, we can know that we might have had like some subversion or inversion of the strata. You might be in the vicinity of a meteor impact if you see that. We look at geomagnetic data. A mascon is a mass concentration, and these orbiting satellites can look for tiny fluctuations in the gravitational field of the Earth, and that relates to gravity, and geomagnetic fluctuations would also be an indicator. We look at topology, the elevation maps, and you can pull some of these things down off the internet. Indeed, some of the things that I'll show you later were discovered by people pulling stuff off the internet. So the data's out there, let's look for it. The telltale smoking guns of a crater, the most important ones that I want to mention, are shock quartz, which I showed you a picture of, the small planar deformations at a microscopic level, and then something called shatter cone. Now I have a piece of shatter cone right here. This is a very unusual rock. This one happens to be from Wells Creek, Tennessee. And if you take a look at this, and you can't see it very closely, but there are these chevron-shaped fracture lines in the rock, and they all sort of point to conic points. If you see a rock that has these chevron fractures in it, and if you look at a lot of rocks, you'll soon be able to identify it, you are either in the vicinity of a meteor impact or you're in the vicinity of a recent nuclear explosion. One of those two events is the only thing that can cause this kind of rock right here. This is from Wells Creek, and it's a piece of shatter cone. This was given to me by Kevin Evans, who's the discoverer of the Weaubleau Osceola structure. And you'll see the small little points and peaks, and there's some beautiful pieces of Wells Creek, large rocks this big, and they sort of come to these points. And the reason this happens is if you think about a rock, which is under pressure underground from all the heavier rock above it, it's under great pressure, and if an energetic impact event happens, it's like a big bowl of Jell-O if you had it in like the pressure cooker. And if you were to strike it with a hammer, I mean, it's almost solid. If you were to strike it with something, it would form these fracture lines that tend to web themselves away from the point of the impact. And those fracture lines show up in the rock as shatter cone points. So, if you want to discover an impact crater, one of the 170, you got to find this to make the list. They want to see shatter cones. We're trying to maybe change and relax the requirements a little bit because we feel like there's some things that are clearly craters that we can't find shatter cones, and Weaubleau Osceola is a good example, which is why we call it a structure and not a crater. We talked a little bit about the shock energy. I'm not going to go into this because we've got a clear night of observation ahead of us, but we do see shattered rock, we see rocks with fine grains, we find shatter cones, and we see high temperature types of rock, like welded spherulites and tektites, little round melt pieces of rock. And this is one of the ways that you have evidence that you're in an impact crater. So let's gallop through that a little bit. Any questions so far? History of Earth craters. The first meteor impact crater. This is Barringer in Meteor Crater, Arizona. I have been there. On the rim, I discovered it cost some $17.50 to descend, so I chose maybe not to go down into it because I had seen the pictures and had read everything I could. This is about a mile wide, and the thing that hit and made that hole was not the size of Texas. It was not the size of Arrowhead Stadium, but it was probably about the size of my wife's minivan. So moving at 22,000 miles an hour, something about the size of a big truck would make a hole about 1 mile from rim to rim. When they discovered this, they did not know what it was. And Barringer actually bought the land because he thought, well, maybe there'll be some gold or some other kinds of iron that we can mine down in it. Indeed, they found fragments of iron, probably from the original meteorite, and radiation and some other things. But this is out in Arizona. It's the most recent, widely known impact crater. It's about 25,000 years old. Now, I could talk about the history of Earth craters, but I think we're going to slip through this part as well. And these are gentlemen that sort of outlined and helped us figure out how Earth craters came about. But note these dates. This was the 1900s. First cataloging was in the 1920s. Shoemaker in 1960 was the first guy that described shocked quartz and started giving sort of a metric to help us decide that we for sure had a crater. And it's only been since the 1930s, 80 years ago, that human beings had any idea that rocks would fall from the sky and make a crater. So this is all recent science. And we're in the infancy of it, and that's why there's still great new things to discover. That's what brings me here tonight to talk to you. But because we can look at the moon, and we're going to look at the waxing crescent moon from the roof of the sky here in about 45 minutes, we'll see lots and lots of craters. And because we see them on the moon, we have to say to ourselves, surely there must be more craters. So we've looked at the crater morphology, simple and complex. This is, of course, the splash rebound caused by that rock coming in, and the mass makes the big splash. Have you seen the slow motion photographs of the milk drops where there's that central thing that sort of bounces up and then falls back down and makes little sub splashes? Those are cool pics. I should have brought that in a little movie to show you. But why aren't there more craters? Well, we've talked about why not. It's because once they occur on planet Earth, they're all subject to erosion. The three largest ones in the United States of America have all been eroded heavily. In the ocean, they get subducted by plate tectonics, We had a good example of plate tectonics a month ago when two of them slipped across each other and created a giant wave in Japan. We have erosion by the water, which, as we know, can pound solid rock up into sand particles and make fun places in the Caribbean for us to visit on spring break. And on land, we have erosion by wind and water. We have erosion by tectonics, earthquake zones, orogeny, mountain building. And we also have simple exposure over time. The sun hits a rock and heats it up. The sun goes down and the rock gets cool, cools down. An ice storm comes and gets into the cracks, gets water down in there, and then when it heats up, it cracks open. These are all erosion processes. So we don't see very many impact craters because they're eroded. This brings us to the Weaubleau Osceola structure. It's the rock star of the night. Weaubleau Osceola structure is the largest untectonized meteor impact crater in the United States. It's about 90 miles from where you're sitting. It was discovered in 1992 by Kevin Evans, Missouri State University, when he was thinking about some odd geology that he'd run across in the area and reading some papers written by Beveridge in the 1950s about the central Missouri area. And all of a sudden, he decided to pull some topo maps down, and he said, oh my gosh, look at that big old circle on that map. That's got to be an impact crater. It's 330 million years old, so it's somewhere in the Mississippian to Permian area of the Carboniferous, which was right after the Devonian and right before the Permian, if I'm not mistaken. Somebody check me on that. I can't actually keep track of all the geology because I'm not a geologist, but I would love to study. Now, it's remarkably well preserved, and the reason is when this thing happened, Missouri and Kansas were at the bottom of an inland sea. And so when the object hit and you had this giant meteor impact occur, it's about 50 feet of water on top of this area. And so when it splashed in, there was a lot of water that was raised up, there was rock that was raised up, this stuff splashed back down, and then it was under the water again. And then when that ocean drained away, and then we had rock building and stuff on top of that, it became buried in sediment, and it was remarkably well preserved. It was as preserved as an Egyptian mummy is in a tomb, and that was only recently exposed by erosion. And that's what makes it cool, because you can go and look at it and pull stuff out of it, and it's all relatively recent, and there's nobody doing it. As a matter of fact, you guys are hearing about the crater tonight, and you're probably a good percentage, 5% maybe, of all the people in the world that actually know anything significant about the Weaubleau Osceola structure, which could turn out to be the largest available impact crater in the U.S. Here we are in Overland Park. So if you drive down 71 Highway, across 13 towards Clinton, that's 65 towards Clinton, and then down 13 you hit Osceola, Missouri, right in here. So here's Pleasanton, Lewisburg. It's about 70 to 90 miles away, depending on if you're a crow or depending on if you're driving. Here's a close-up of the area. The Casinger Dam that made the Truman Reservoir is up here somewhere, and this is the old course of the Osage River, which curled through here. And here's the town of Osceola. Now, I was talking to Bill and Doug. We were talking a little bit about regional history. This is off the beaten path a little bit. And we happened to be talking about the Civil War and some of the causes of it. And I happened to remark that the biggest, deadliest act of terrorism ever committed on U.S. soil, domestic terrorism, before the Oklahoma City bombing, was of course when Quantrill gathered on Mount Blue and then descended on the town of Lawrence, Kansas, and just killed every human male in the city. And there was about 200 deaths. But the reason he did that, it was in retaliation for something called the sacking of Osceola, where the border raids came across the Missouri-Kansas border, and they came over and they chose Osceola, which was the county seat, and it was a kind of a big deal, and it was a growing town, and they leveled the place and then retreated back to Kansas. And so the reason Quantrill came over and leveled Lawrence was in response to Osceola. So this is all like tied in with how humans behave in the Civil War. Now, if you look at this picture, which has been up here now for 90 seconds, and you look very faintly here, what can you see? Probably a circular region coming here. We're going to make a negative of that This is the thing that's gotten our attention. So let's take a look at it. Here's an elevation map, and once again, here's the course of the river, and this is the aerial map. And you'll see this area right here, and you'll see a ghostly nether structure right here, which is almost a perfect circle. Can you see that? And then right there is the central uplift. That's the splash that occurred when the object hit. Giant splash, and it came down right there. The town of Vista, Missouri is located right there. And many of these rocks are from that area. Here is what he calls shuttle radar topography of the Weaubleau Osceola structure. And you get, once again, the structure coming through here. This negative image shows you really clearly the central uplift and the subcrater right there. Can you see it? Now, if you were standing here, what would you see? Well, that crater is about 10 miles across. And if any of you have been on Highway 13, you come up to Osceola, and there's that Osceola cheese store on your left. And just as you come up there, there's this long, gentle upgrade that you sort of have to drive up. And when you're driving up that, you're actually driving up, the highway's right there, you're driving up this little hill right here towards the rim of the crater. So you're not aware that you're in it. If you've been on Highway 13, you've been in it a bunch of times. But there's cool things to see in there. Now, I'd like to point out that it's not the only impact crater in Missouri. Here's Weaubleau, Osceola right here. Here's another one, and this is Decaturville. And you can see this little circle on the topography map. Can you see that? So this is also a structure. It's not a crater. We haven't found any shatter cone there yet. But they're very close together, and that lends us to something like, if they're close together, are they correlated? So we'll talk about that once again gallop through it. Here's a look at the Osceola structure on a explanatory map of its structure. You can see how the full shock folds are in this area here, and as you can see, here's the valley floor, which is undisturbed. Here's the crater itself. Here's the inner ring, which is uplifted. And these are all the interior brecciated areas right here. There's a quarry located right there that I've spent some time in. As a matter of fact, I pulled some big rocks like this guy right here I pulled out of the quarry. And I've actually have some bigger rocks that I didn't bring because to hump rocks into a lecture is like, I mean, it's like you can only bring so many rocks. There's a lot of heavy rocks here, and I didn't actually bring a whole bunch of them. I got some big rocks I'll show you. But we found that inside in a quarry, and some of these actually came from that quarry. Many of these rocks came from a little area that I found, which is right where the highway passes the central uplift area, right in there. The Missouri Highway Department has drilled a core sample 800 feet deep, and we're trying to help them help us figure out what we have here. I say we, it's because Kevin Evans, after I found out about Weaubleau, I called him up, I introduced myself, we became co-interested. I've accompanied Dr. Evans on several of his field trips. I know some of his graduate students now, and have had ongoing conversation at night and in our spare time and over a drink at times to talk about what we're learning about the crater. But the going is slow because everyone's busy with their work, and you can't do this full time because it's hard to do for me, because I don't get paid to do it. Once again, it was 330 million years old, covered quickly by ocean sediments, and only recently exposed. All right. Let's look at some pictures. First, let's talk for a second about it. It's long known to be very unusual in geology because there was the brecciated area, and also people would find these strange round rocks. And nobody knew what they were or what could cause these round rocks to happen. And people were always finding them and going, what do we have here? What could cause this round rock to happen? Because you don't see a rock like this, especially one this light. If you were to hold this rock, you'd go, this weighs about half of what I expected to weigh. It's very light. And I'll tell you why in just a second. There were some odd theories about cryptovolcanism, which basically was one of these conglomerate ideas where somebody said, well, what if you had a volcano that was underground and it made a bubble of gas which rose to the surface, and that like broke some rocks, and then it like escaped into the air like a giant bird through the cracks, and you know, it was a sort of a made-up explanation because no one could understand what it could be. It was truly a theory that didn't have any support. But in 2003, Kevin Evans took a look at satellite map features and the brecciation, and he also did a little bit of research later and found shock quartz, but we didn't find any shatter cones. Where are they? I have an area of interest right here. And this is Coon Creek shooting right here next to Highway 13. And it flows right along the river tree line here. And my friends Todd Fritz and I and our sons, we're going to put in right here by Gerster maybe sometime this summer. And I'd like to look at the geology of this area, because if there are shatter cones, I think we're going to find them right in here. The central uplift area is right here, but because the object came in from this location, from the southwest, and I think if it threw some rocks and shattered some rocks, they would be sort of in this direction underneath. So this is the area I'm interested in looking at, canoeing this river right here. So if anybody wants to go canoeing this summer and have a little geology trip, let's go. We find these round rocks. Now when I was a kid, I went to the Boy Scout camp down by Osceola, and we had these legends of these round rocks, because some guys said, well, then you can occasionally find these perfectly round rocks. And I looked and looked and looked, and I could never find one. As a matter of fact, the only one I found when I was a kid was this guy right here. But when you hold this rock in your hand, you'll discover that it's much heavier than the other rocks. And as a matter of fact, this isn't a round rock at all, although it's a spherical rock. This is something that was eroded by hundreds and hundreds of years tumbling down a riverbed of some kind. So that's a round rock that's not a round rock. But you can see this picture is right off the wiki page on the internet, and it looks just like this rock here. And I've collected dozens and dozens of specimens of this rock. And we used to call them weef eggs because we had this little story about this mythical creature called the weefus that would go around and lay these eggs, and they would roll down to the bottom of the hill, which actually wasn't far off. Because when these erode out of the rocks they're in, they'll roll down the bottom of the hill because they're spherical. And we'll tell you why in just a moment. Now, we're not sure what they are. There's a concretion theory, and Kevin and I are both pretty big on the concretion theory. Concretion theory says that there's a small piece of shale from the basement rock that was scooped up when the object hit. And indeed, if you break some of these rocks open, and I have my hammer, and if we get enough time in a couple minutes, we're going to smash a couple of these rocks and see what we get. But if you look inside this rock, you'll see that it has this little yolky area broken in the middle. And that is really crumbly and soft, and it's green. So every one of these rocks has got this odd green core inside of a cave. And as a matter of fact, I want to show you this rock, which I pulled right from the upper core. You can see that this is a very old eroded rock. And you can see the cave in the middle, and the little piece of shale is quite eroded out of it. So this is a great example of a Weaubleau egg. It gives you an idea of how they develop. Yes, do we have a question?
Do rocks that come from outer space, do they follow the same class system as the three classes we have for rocks here, or are they different classes?
They don't, and I'm going to tell you why in a little bit. We get rocks from space, and the basic kinds are the stony meteorites, and then some other kinds. The ones that are identified with Mars have a certain characteristic geology to them, and these rocks here are earthly in origin. Although the rock I'm holding in my hand, because it's got a yolk inside, this little piece of shale that was scooped up in the bedrock, it was probably thrown 20 to 25 miles high, and it rained back down into the ocean, into the sediment. And then they served as the seeds, and the concretion formed around them over millions and millions of years. So yes, this rock I'm holding in my hand is probably the only rock you'll ever hold that's been to space and back. So that's why it's one of the reasons why they're interesting to me. They're a little romantic.
There's no scientific name for what the rock would be.
It's probably called a chert concretion, but the Weaubleau eggs are unique to the Weaubleau area. If you find one of these, and unless somebody like moved it to their garden or something, like me, they brought them up to Johnson County, Kansas. If you find one of these rocks in its original location, you're within 10 miles of Osceola, Missouri, because it's the only place you find them. There are some other kinds of concretions that occur, and I'll probably skip over talking about those. Actually, we may talk about them in a second. But that's the only place that you find these rocks. Here's an enormous egg, and you can see right in here is the layers of rock that have concreted around, and at the very center of this you'll find a big green shale core, which we call the yolk of the egg, and that's why they were originally called eggs. And this rock I want to show you here, for example, here's one that I saw it open here about 3 weeks ago. And if you look at it, you can't see it from here, but you look at it, you'll see there's a little green piece of compressed shale right in the middle of it. And you look at these other rocks that have the same things. We'll crack a couple open and take a look. Here's a great example. You can see this greenish rock inside this piece of this Weaubleau egg. I know you can't see that, but I want you to come up and look at my collection handle it in just a second. We're almost finished. We're coming to the slideshow part, which is probably the interesting part because it's got people in it. So as you can see, this is me holding a rock that I had just picked up, and I just showed it to you. That's this one here. This is Dr. Evans, and he's talking to some geology students from Missouri State University, and they graciously extended an invitation to me to join them on their field trip, which was a great fun for me to do, and I learned to keep my mouth shut and listen to the students as they learn, and it gives me a lot of interesting, cool information to learn. So I got this right in the central uplift area, and it was eroded out in this little stream, right here is this little sort of stream bed, and he sort of walked up, so we stepped up to there. And this is the central uplift area, and it actually has this sort of raised slope, which kind of goes over to here, this general slope. So once you're in it, you go, well, that's actually pretty neat, because that's actually what it does, is to raise itself and uplift. This is my son, Corey Johns. He's a 7th grader, and he took 3rd yesterday in the 800 meters at the Olathe City Track Championship. And hooray for him. He ran a race of his life and broke his personal record by some 10 or 12 seconds, and so it was quite a surprise to all of us. But you can see that he's discovered a couple of Weaubleau eggs, and these are buried in the rock. Here's one that's round, here's one that's come to the surface and completely weathered out, because you can see the yolks broken open, and here's a couple of Weaubleau eggs in the rock. And this is Highway 13 in the background, and this is near the Vista 1 core that the Missouri Highway Department graciously drilled for us. My son loves to collect leaf eggs. It's like an Easter egg hunt. This is what we call a nest. I found some Weaubleau eggs, and they were tumbling from this crack in the rocks. This is called a karst, because it's a broken area between two uplifts, two small uplifts. And you can see we have several Weaubleau eggs, some of which you might see on the table, and they're eroding out of the rock. Some of this stuff is not, it's just pieces of the breccia, and they're not concretions. But you have these concreted Weaubleau eggs all the way through there. There's a lot of interesting rock that's not Weaubleau egg, but I, for some reason, am interested in these Easter eggs, and I'm not sure why. It's just a fun thing to know about, and to my knowledge, there's only one other guy actually, collecting them or interested in them. And David couldn't be here tonight because he's teaching for the ASKC out at the observatory in Lewisburg. This is Dr. Evans, and he's holding what we think is the largest Weaubleau egg that we found. This is on a little pedestal right at the confluence of the Sac and Fox River. And it's way out in the country. It's a great scenic place. And you can see that some guys have built a little bench made of Weaubleau eggs right over here. This structure is probably 30 to 40 years old. They didn't know what they were, but they built like a little bench out of concrete and round rocks. You keep finding these things all over Osceola. It's like they didn't know what they had. And this is an enormous egg with a concretion around it. This is my good buddy, Todd Fritz. Todd and I have sons about the same age, and this rock is sitting on this pedestal, so if you wanted to hoist it up, or I guess steal it, I mean, you could, but it'd be a shame. It's been sitting there for probably 40 years, and I hope no one ever takes it. It just goes to show you that there are some places in the country where people still trust each other. Because I wouldn't trust this guy. He'd run off. Actually, I wouldn't trust Todd if you knew him. If anybody knows Mr. Fritz, forgive me, Todd, but one of these days he's going to go steal that thing. Here's a house in Osceola, Missouri, and they've actually took these rocks, and I'm sure he sawed them open looking for geodes or jewels or crystal caverns of quartz inside these rocks, and he built these stone pillars out in front of his house. I don't know who lives in this house, but these things are quite old. I guess someone named Calvin lives in this house, and these things are quite old, and I didn't know what he expected to find. Here's a close-up. I hope that he didn't object to me walking around his property and taking pictures of his post, but they're probably more interesting to me than to him. You can see somebody saw this one away from that one. Those clearly match. And it looks like these two match, and maybe that one and that one match, but this one actually had some vandalized. Somebody spray painted it. But if you had only a little bit of concrete and you wanted to save some building material costs, then you could build them into the pillars. So I think that's quite interesting that they've done that. This is new. This is 50 years old, and these rocks are about 335 million years old. So kind of cool. There's other geologic concretions. As I wrap it up here, we have Moki balls, which you find down in Arizona, and they're called cannonballs. We have the Kansas rocks, which are called pop rocks, and they're hematite. We have Bowling Ball Beach in California. Here's some pictures. I'll scout through this. These are the Moki balls you find in Arizona, and they're hematite concretions, which form about the same way. So the mechanism is understood, but the specific shale concretion bottom of the ocean sediment we've never seen anywhere else on Earth than Osceola, Missouri. Kansas pop rocks. These are called Bogai balls or Bogie balls. They're from the Smoky Hill Chalk area down in Grove County, where there are exceptional marine fossils, especially of reptiles. Many museums have these fossils. If you see plesiosaurs and maybe these skeletons of sea turtles, that just, when you see them, you go, holy smokes, man, how could you imagine seeing that fossil? And a lot of these came from Kansas and from that area. And as a matter of fact, I discovered this picture I stole from an astrology page, because this one is a male. No, this one is a female. This one is a male, and you take the two together and rub them or cast a spell on them or juggle them or something, and you can actually perform feats of magic and legerdemain with these rocks. I doubt it. But they sell them on the internet, and you can buy them. Now that raises the question, can you sell a rock like this on the internet? Every now and then I see somebody selling these rocks on the internet, and I've seen rocks like this to unsuspecting buyers go $10 or $15. So it's possible that if we together work to spread the word about Osceola or Weaubleau, and it becomes a crater, not just a structure, like if I find some shatter cones, then maybe these rocks will all be worth 10 or 20 or $50, and the ones that you swipe for me tonight when I'm not looking, you can sell anyway. This is Bowling Ball Beach in California. Once again, the slideshow section. I haven't been there. I swiped these from the internet, and these are round rocks that have eroded out of the hillside and fallen down over millions of years. So these aren't rocks that just like eroded on the beach like sand, but they eroded out of other rock. And we have the Martian spherules. These are another picture. This is a picture from the Mars lander, and he came across these like little round balls, which have these little characteristic impressions. A lot of these Weaubleau eggs have a little hole, because there'll be a little place where a crack in the rock sort of starts getting through, and if you look down in that rock, you'll see the green shale down in there. And so you'll see a great many of these rocks that have kind of a hole or a start to a hole. Look at the hole in this guy, see that? Or this little guy right here. Or let's look at the bowling ball. This is the rare double-yolked Weaubleau egg, which is not particularly well explained by the concretion theory. How could you form a rock like this? How could both these rocks concrete around each other and join and then erode out of the rock? Well, the concretion model explains it best. We don't totally understand the mechanism, but we're working to understand how this rock came about. That one's called the bowling pin. It's right in there next to another double, which is called the peanut. These are rocks from my collection. Okay, we're about finished. We're going to talk about the night sky and talk about my rocks. We have some rocks I'm going to show you. The smoothie is on loan, and it's the smoothie and the Willendorf aren't with me tonight because I loaned them out to somebody else to see. But we have the cannonball, which is down here. No, the cannonball's not here as well. But we have the Klein bottle, which I'll show you. We have Peanut Man. We have Picasso's pipe. And we have the laser lander, which I keep on my desk at home. A nice little teardrop-shaped Weaubleau egg that I used to park my I keep that on my this is actually a very interesting rock, because you can see it's not round, but it's got this sort of teardrop-ish shape to it. There's some people that are conjecturing that the shape of this rock and the shape of other round rocks, like perhaps these, just look at this double yoke, and you also find a lot that have these teardrop extensions on them like that, and they think that maybe these were shaped because they were actually falling through the atmosphere, and that their very shape was based somehow on the speed at which they were going through the atmosphere, and friction helped cause this. I haven't come up with a mechanism that makes sense for that, but that's what I have so far. That it's a pretty typical thing to have a hole. So this is called the laser lander, and I keep my so we have some fun with this. I'm going to skip through this. This is the serial impact theory, which basically says that there's 3 or 4 structures along the 38th parallel. Could they be related? We have Crooked Creek and we have Wellsville, which are right here on the map. Crooked Creek here, Wellsville right by, Wellsville, I'm sorry, is over here in Kentucky. We have Crooked Creek and Decaturville. Did I have a typo on the slide? Yeah, I'm sorry, it's Crooked Creek and Decaturville. They're impact structures, but we have these other events here, and it's possible that if we could constrain them in time, we could have affirmation of Shoemaker's theory since 1989, where he saw the comet hit Jupiter, and that's what really caused us to start thinking about serial impact events. If they could happen on Jupiter, could it happen here on the Earth? That's just only about a 25-year-old idea. And if these could be constrained to about the same time, then maybe they're all related, and we saw the breakup of some huge cosmic object, maybe the size of Texas, that broke up and scattered its energy across Missouri and Kansas there. So we've got more to do. Once again, you've seen this slide. These are, constrained across like that. That's about it. We're going to talk about the night sky next. And I would encourage you, I would be wrong if I didn't offer my support to the ASKC. This is the Astronomical Society of Kansas City. You can read more about it at askconline.org. Dues are not very expensive, especially if you have an interest in astronomy. It's a wonderful group of guys because you got high-end pros, you got guys that would be happy to help you understand how your telescope or your binoculars work. And the coolest deal about it, oh, excuse me, how did I get back to there? The coolest thing about the ASKC is that we have Powell Observatory located in Lewisburg, Kansas. That's about 25 miles down the road. It is the largest telescope within 8 states that's regularly, indeed, one of the largest in the United States that's regularly available for public viewing. The fact is, if you go out to Lewisburg on most nights, on the weekend, you're going to chum up with somebody and you'll be able to get up in the cage and get your hands on this 30-something inch massive telescope, and to take your cell phone and hold it up to the objective of a massive telescope and look at the rings of Jupiter and get a picture on your Facebook page. I mean, it's a fairly cool, fun thing to do, to think that, we sort of have that and it's in our backyard. We're spoiled. We're going to go on the roof and look through some nice scopes that Doug and Bill are going to take us to see, but it's nothing like looking at the giant 30-incher out at Lewisburg. So that's what the ASKC has to offer. Tonight's sky is happening outside as we speak. We have the waxing crescent luna, about 4 days after new moon, or maybe 5. And so we'll be able to maybe see some craters on the Terminator. And we'll be able to use my astronomy binoculars to do that, along with Doug and Bill's telescope. These are my astro binocs. I'm more a binocular kind of observer. I'm more a Curious George kind of guy than I am a telescope guy. Partly because those are very useful for looking at birds or for taking to the Chiefs game. But also because telescope observing is really for the patient, and I'm just a little bit ADD sometimes, and maybe it's more fun for me to have a lawn chair and I have a more romantic view of the overall night sky. I'm more interested in constellations and the Milky Way and some of the binocular galaxies than I am just dividing 2 stars into 3 in deep space. Besides that, I have a lot of guys in the ASKC that love to do that, and so I can hang out with them and I can teach them what I like, and they can teach me what they like. Tonight we'll be able to see Saturn. The other planets are in the morning sky. As a matter of fact, there's this fairly spectacular conjunction coming up. What do you know about that, Bill?
Well, we've got on the eastern sky. We've got,
how long away is that? Maybe a couple weeks?
No, that's
I can't remember. It's like this week?
Yeah.
Gosh, I get mixed up. But you can only see that early in the morning. You'd have to get up about 5 a.m. to start seeing that. It's almost just before the sun comes up, right?
Yep.
We'll be able to see the circumpolar constellations, which are those that never go under the horizon at our latitude because they're close to Polaris, the North Star, and Ursa Minor, and therefore they never descend below the horizon. And that leaves Ursa Major high in the sky. So we'll be able to see that. We'll be able to follow Ursa Major's pointers from Arcturus and Bootes down to Spica, the Virgin's Jewel. And the most interesting constellation, of course, is Leo, who rules the sky tonight. And we'll be able to see Regulus, Denebula, the backwards question mark, and all the cool high early spring constellations. The winter sky is fairly interesting, and we'll be able to see most of those stars set. The stars that you've heard of in Orion, like Sirius, the brightest star in the night sky, you'll be able to see for about the next 45 minutes to an hour. There's one more thing happening, and that's we are at the peak right now of the Eta Aquariid meteor shower. Now, this is one of the minor meteor showers, but it's interesting because it's associated with Halley's Comet, which is the most well-known of the periodic comets. It has a 76-year period, and because it flies around and intersects the orbit of the Earth in two locations, we have one in the spring and one in the fall. So this peak now is May 6th, May 7th, and we'll hit the peak tonight, early in the morning tomorrow. Now, the bad news about that is that the radiant is in Aquarius, the water bearer, which is down like close to the horizon. And as a matter of fact, the farther south you get, like the southern hemisphere would be the best observing for that. But there's cool things called Earth skimmers, and if we do see a meteor, a meteor trail, we'll see an Earth skimmer. You have to stay up till 4 or 5 o'clock in the morning to see that. So if you want to hang out, maybe you can. Back to Curious George. Once again, he's a binocular guy like me, not a telescope guy, and he's curious about a lot of things. One thing he's curious about, and Bill challenged me to bring this up, and this is what I'll close with. Thank you for your patience. He's curious about how to memorize the order of the constellations in the zodiac, which are, of course, the Ram, the Bull, the Twins, the Crab, the Lion, the Virgin, the Scales, read it with me, the Scorpion, Sagittarius the Archer, Capricorn the Goat, Aquarius the Water Bearer, and Pisces the Fish. Now, recently, about 6 months ago, there was a big article in the paper, and you guys all probably read about it on Facebook, that, hey, it turns out there's 13 constellations in that zodiac. We need another month for astrology to be accurate. Actually, there is another one, which is the serpent bearer, Ophiuchus. It does happen to descend into the zodiac, but there's only 12 months, and so we conveniently leave him out, so it's all good. All the math works out. It's just another evidence that astrology is just a little bit crap. So how does Curious George remember this? In a previous evening with the stars, I told you how, and he has a little jingle that he remembers, and we're going to learn this together. And this is from author H.A. Ray, and here's what he says. The Ramble Twins crab liverish scaly scorpions are good water fish. If you can memorize that, you have the Ram, you have the Bull, you have the Twins, Gemini, you have Cancer the Crab, you have the Lion and the Virgin, liverish, and we add fish because it makes that rhyme with fish. And we have scaly scorpions, which of course are Libra the Scales and Scorpius the Scorpion. R, that's the Archer, Sagittarius. Good is the Goat, Capricorn. Water is Aquarius, the Water Bearer. And fish is the Pisces. So we have Ram, Bull, Twins, Crab, liverish. Scaly scorpions are good water fish. And this is how Curious George remembers the constellation of the night sky. One more note before I close, and that's I was going to bring you a book tonight. If you are interested in introductory astronomy, the book I recommend is a fairly simplistic book. It's by author H.A. Ray. Now, H.A. Ray happens to be the refugee from World War II that was able to, on foot and bicycle, escape Hitler's invading Paris and made his way to America. And even though he was working with his wife, he managed to write this cool book together under his own name, which was really, his wife wrote the stories. And the books were called Curious George. This is the author of the Curious George books. And so H.A. Ray also wrote a book called The Stars, A New Way to See Them. And this was a revolutionary book because he would take a group of stars like the Gemini twins, and he made a new series line between them, and it gives the illusion that you're looking at twins, because the stick figures look like twin guys. And the old asterisms in the night sky, which I pointed out in my last lecture, made it impossible to memorize star shapes. For example, if you saw that shape of stars, you'd go, what is that? I don't know what shape of stars that is. It happens to be Leo the lion. Do you see the lion? There it is. And there's a big star in his foot. Here's the backwards question mark. Here's the body of the lion. And H.A. Ray says here's the Neville and the tail. And here's what his legs can look like. And this is a much easier way for me to remember what Leo looks like than to just see that in the sky. A lot of your textbooks that show the patterns with all kinds of different lines, the lines don't make sense. What Ray does is he goes back and redraws the lines in a way that helps you remember what's what. And he's the same guy that wrote the Curious Georgia books about the curious, happy little monkey. So everything sort of falls together. Thank you. I'm Leo Johns with the ASKC. It's my pleasure to get here and be able to speak to you about my rocks. My collection is open for your inspection. If you have any questions, I may know some answers. I might not, because I'm just learning about this stuff myself. I'm an amateur, and I challenge you to take your amateur status, probe into things you don't know about, and learn what you can. Thank you very much. Appreciate it.
Okay. For those of you who are wondering what the hell